1, 2. The first A is titled Angles in the Coordinate Plane, and by the end of the lesson, you will be able to define and identify key aspects of an angle on a coordinate plane. Okay, so coordinate plane is basically your x-axis, your y-axis, and your angles are going to be measured in degrees, and one full rotation would be 360 degrees. When you see these Greek alphabet symbols, they are referring to angle measures, and the three most common that you're going to see are the theta, the alpha, and this one called the beta. Are there others? Yes. Will they randomly pop up? Yes, but the three most common and main ones that you're going to see are those three. You should probably memorize those three. If you are, when you go to college and you want to join a fraternity or sorority, they're going to have you memorize the whole Greek alphabet. You'll be 3 steps ahead. Okay. All right. So when you have an angle in the coordinate plane, it's going to have what we call an initial side and a terminal side. Terminal just means the end, like if you're dead, you're terminal. You guys heard that before? Yeah. So it's the end. All right. Any questions on that? Okay. All right. Next box down, talking about when your angle is positive and when your angle is negative, and looking at it clockwise versus counterclockwise. So your positive angles are going to start at 0 and go counterclockwise. Those are going to be your positive angle measurements. And when they start at 0 and go clockwise, they're going to be negative. Any questions on that? That's pretty straightforward. Okay. I'll try to keep that in view. And down at the bottom, there's nothing to fill in, so that you just need to look at it and see what the quadrants are. So angles lie in the quadrant in which the terminal side rests. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You notice that they use Roman numerals, so Roman numeral 1, Roman numeral 2, and so forth. And notice where they're positive. So this one is considered positive, this one is negative, and so forth. Okay. Any questions on that? Anybody still writing? Okay. Give you guys a sketch the following angles and determine which quadrant the terminal side lies in. Okay. So for A, they want us to draw a positive angle of 120. So we're going to start at 0. Straight up would be 90. So we know 120 is going to lie at end. Its terminal side is going to be in quadrant number 2. Let me try and make that perfectly straight. There we go. Sort of closer. All right. For B, they want a negative 26 degrees. So we're going to start right here. It's going to go counterclockwise, negative 26 degrees. It ends up in quadrant 4. For C, they want a positive 200 degrees. So if we start at 0, here's 90, here's 180. It's a little more than 180, so it ends up here in quadrant 3. For D, they want a negative 389 degrees. So negative 360 would be a full loop, right? So if we're starting at 0, one full loop plus a little bit more, 20, what would that be, 29 more, puts us down here in quadrant 4. And then for part E, we've got positive 801 degrees. So that's 2 full loops plus a little bit more. So we end back up in quadrant 1. Not a super lot to write down here, but there's a few things, okay? So now we're going to introduce to you what we call the reference angle. And so for any angle theta not lying on an axis, the reference angle beta is going to be an acute angle formed by the terminal side of the angle and the x-axis, okay? So for this first box, it says quadrant 1, we have a 60-degree angle, and if it's there, it's its own reference angle. For this box, we have a 120-degree angle, which is more than 90, which is going to end us up in quadrant 2. So the reference angle would be drop down to the x-axis. The x-axis is always the horizontal one. And what's left from 120 of the difference to 180 would be 60 degrees. So the reference angle would be the 60 degrees. Let me zoom in so you can read my writing there. It says how much it takes to get to the x-axis. So if you've gone 120 and you need to get to the x-axis, you need 60 more. So the reference angle is 60 degrees. Okay? In the third box, which is, they put it quadrant 3, very clever. Okay, so if the angle measure is 240, we want to get back up to the x-axis, and that would be a 60-degree reference angle as well. Okay, and then the last one is a 315-degree angle, which ends up in quadrant 4. You subtract that from 360 to get back to the x-axis, you would have a reference angle of 45 degrees. Okay, so you guys are going to practice these in a second. Okay, any questions on the reference angle? You may need to reference back to this page. Okay, math jokes. Okay, up at the top of page 5, it says, for each of the following, let me shrink it just a tad. For each of the following, the measure of the given, for each of the following, determine the measure of the given angle, then determine the value of the reference angle. The duplicating is very faint. It's pretty hard to see. So they're giving us, I think it says 100 or it says 109. I can't read that. It's just 100. Okay. So it's, and I believe it's negative. Negative 100 is the given angle, which puts us over here in quadrant 3. So to get the reference angle back up to that x-axis would be a difference of, bless you, would be a difference of 80 degrees. So that reference angle would be 80 degrees. All right, let's try another one. B gives us a given angle of 315 degrees, which puts us here in quadrant 4. So to get to the x-axis, to get our reference angle, in this case, we would subtract the 315 from 360, and our reference angle would be 45. Okay. And for part C, our given angle is negative 490, which puts us here in quadrant 3. And then to get back to the x-axis, because there's 40 degrees here, that means there's 50 more here. So our reference angle would be 50 degrees. All right. Down at the bottom, it says the terminal side of angle theta is in quadrant 3 and has a reference angle of 42. What is the angle if it's positive? If it's in quadrant 3, I think this answer is wrong. So it should be down here in quadrant 3, and it should have a reference angle of 42. That means it should be 180 plus 48. Let me see. 220. What if what if it is a negative angle? It should be going this way, so it should be 180 minus 42, but then it would be negative. Negative 138. I was showing the wrong quadrant. Let's fix that. There we go. Okay, flip over to the top of page 6. And now we're going to talk about the coterminal angles when you add or subtract multiples of 360. This K just means you can keep multiplying by 1, by 2, by 3, by 4, by 5, as many times as you need to. Okay, so for K is just an integer, like 1, 2, 3, or even in this case, negative 1, negative 2, negative 3, negative 4, and so on. Okay, so 2 or more angles that have the same terminal side. Okay, so if we have this angle right here in quadrant 1, it is 30 degrees. If they say, give me 2 angles that have this same terminal side or have the same measure, you can either add 360 and get an angle of 390, which is which one? This one. So if you start here, go around, add 30, has the same terminal side. Or you can start with 30, subtract 360, and go clockwise, and you'll end up with negative 330. Okay. You can keep doing this if they want 3 or 4 or 5 or 6, how many ever they say. You can keep multiplying that 360 by 2, by 3, by 4, by negative 2, by negative 3, by negative 4, and get more and more, how many ever they ask you for. Yes? Name 4 angles, 2 positive and 2 negative, with a that are coterminal with 60 degrees. Okay? So we start with our 60. I added 360, got an angle measure of 420 degrees, and then added another 360 degrees, got a 780. We could keep going, and we could keep going, and we could keep going. Now we're going to get some negative. So start with 60 and subtract 360, which gets us negative 300 degrees. Then from negative 300, subtract another negative 360, and we end up at negative 660 degrees. We could keep going. Subtract another 360, subtract another 360. Okay, so for part B, it says, name all the angles that are coterminal with 60 degrees. If we listed them all, we would run out of space. Like, it would be infinite. Okay? So we're just making a general rule. It's going to be the 60 plus or minus 360 over and over. They even back up here, put the K, right? Any integer, you could keep finding more and more and more. Okay.